Alright, welcome to part 4 of our Unit 5 project. Consider the following problem. An airplane travels 1,000 miles on a bearing of 210 degrees. Then it changes the bearing to 270 degrees and travels 500 miles. How far is the airplane from the starting point? Alright, so we have a bearing which is due north, 210 degrees, and it travels at that angle for 1,000 miles. And then at 1,000 miles from due north, they change to 270 degrees and travel another 500 to the ending point. So they want to know from our starting point to our ending point, how long is that? So we're finding a side length of a triangle. And we will solve this problem step by step. So what is the measure of angle ABC? So from A to B to C, they want to know this total angle. And if we notice, this angle is made up of two parts. It's made up of this portion, and it is also made up of this portion right here. So we're going to first find the remaining part from 270 degrees all the way around. So if we made a complete circle, I would be back to the beginning and I would be able to find this section of our angle ABC. So then I'm going to say, okay, that section, if I have a whole circle here, would be what's left of the 360 degrees. So I'm going to take 360 degrees and I'm going to subtract the bearing from it, which is 270 degrees. So 360 minus 270 is 90. So that portion has an angle measure of 90 degrees. But that's not the full angle measure of ABC. We have this little portion that is beyond what our bearing is. So if we are to look at this, we just found from here to here, from our bearing to the side length BC. So we just found this portion of our angle, and now we need to find this portion, the remaining from our bearing to the side length AB. So how can I do that? I know that I can have parallel lines, and due north being due north would create two parallel lines, and we have a transversal here, the side length AB. Now from transversals, I know that alternate interior angles are congruent, alternate exterior angles are congruent, and so I need to find a relationship there. So the remaining part right here of our angle ABC would be an alternate interior angle to this portion of our first bearing. It's not the full 210 degrees, it's just a portion of that. So I have to find a way. How can I find this portion of the 210 degree bearing? I'm thinking to myself, okay, well, I know that from due north to due south creates a straight line. So then I know that that would be 180 degrees. And so I know that to get from 210, I need to subtract 180 to find that remaining portion. And 210 minus 180 is going to give us 30 degrees. So this section is 30 degrees of our angle, and this section we had found to be 90 degrees. So the total angle, the angle addition postulate, is 30 plus 90 degrees. So that is 120 degrees. Now, step 2 refers to problems. Now you know that the measure of angle ABC in triangle ABC. Which of the following laws would help you find the length of AC? So the length of AC, the laws, is it going to be the law of cosines or the law of sines? So I'm going to ask myself, in order to determine which one I need in order to find that length, I've got to find out what is given. So I know a side length, and one angle. And this angle is 120. And if I'm looking at the law of sines, law of sines is a proportion setup. It is the length of A, the opposite side, to the sine of that angle A. So it's the side length compared to the sine of the angle would equal B over the sine of our angle B, or it would equal our ratio of our side length C to compare to the sine of our angle C. And if I am looking at this, if I were to use a proportion on that, I could use any two of these just by the transitive property. But I'm going to notice that little a represents side length A, which would be 500, and sine of A is right here in the triangle. I don't know that angle, even though we may know the side length B is the one that we're wanting to find, and I have that angle. I could set up the proportion looking like 500 over sine of A is equal to an unknown, which is what I want. I want to know that total distance over the sine of our angle B, which was 120 by substitution. But since I have a missing angle here and a missing side length, I cannot use this law of sines because there's two unknowns. So then the law of cosines is that c squared, or a hypotenuse length squared, is equal to a side length squared plus the other side length squared minus double our side lengths being multiplied times by the cosine of c. So now I'm going to look at this and I'm thinking, okay, well, if I were to use the labels right now given on this diagram with this formula, it is not solving for side length AC because AC would be labeled little b, which is right here, and this one set up as is solving for little c, which is right here, which is already given. But I know that the law of cosines is a relationship equality. And so if I look at this, I'm thinking, okay, what angle is it having me use? And it's having me use angle C. And I'm asking myself, okay, what's the relationship between the side that it's set up to be found and the angle? And there's opposites. So in this equality right here, we have that it's finding the angles, it's using the angle C in order to find its side length, little c. And then it has the lengths of the two adjacent sides to it. And so I know that by that relationship, I could rearrange my labels. So I could say, well, if I want to find side length little b, I'm going to rearrange this based on the relationships. So I'm finding side length little b, so I'm going to have b squared. The side length that I'm looking for is going to equal a squared plus c squared, which is the two adjacent sides, compared to our angle b. So we have a squared plus b squared minus 2ac times the cosine of angle b. Now, that is holding true to the relationship. The side length is going to be opposite the angle we want, and the side lengths that are used on our right-hand side are the side lengths that are adjacent. That's kind of a logical explanation for why we can do this versus I could write it out in algebra to prove it, but it would take a long time. So I'm just going to go with our logical relationships between these. So I'm going to use the law of cosines, and we're going to use our substitution property of equality. So we know that if I were to label this triangle, that side length AC is little b because it's opposite that angle. Side length little a is opposite angle A, so this would be little a. And side length C, little c, is opposite angle C. So those are our side lengths, and now we're just going to use substitution. So we have side length b squared, because I don't have that length, is equal to a squared, which a is equal to 500 squared, plus c is equal to 1,000 squared, minus 2 times 500 times 1,000 times the cosine of our angle b, which was 120 degrees. So now, cosine of 120 degrees is a ratio, so I know that that is a number. And I can type this into my calculator as we can type in, make sure that your toggle switch is in degrees. So we can type in 500 squared. We type in x to the y. We click the x to the y button, 2, plus 1,000 x to the y, 2, to get our squared, minus 2 times 500 times 1,000 times cosine of 120. And then click enter, and that is 1,750,000. Now, if you're thinking that's huge, so we had b squared is equal to 1,750,000. That's way too long. You're right, it is. It's because that side length is squared right now. So the inverse operation of squared is to square root. So the square root of b squared is b, and that's going to equal the square root of this number. So we're going to square root it. Square root of 1,750,000. And that is going to equal 1,322.8756. Now that is a much more logical distance that it had traveled. So, enter your answer as the number rounded to the nearest hundredth. Alright, so then I need to round to the nearest hundredth. So this is the hundredth place, so I go to the one to the thousandth, and I ask myself, is it 5 or higher? Yes. So then that means I need to round up to an 8. So that means that it traveled 1,322.88 miles. Explains the steps you took to solve questions 1 and 2. Support your decisions using mathematical reasoning and justification. Alright, so step 1, we use the angle addition postulate to find the measure angle ABC. So we first found the portion of angle ABC created by the bearing 270 degrees and due north. So we took 360 degrees and subtracted 270 degrees, which resulted in 90 degrees. To find the remaining portion of angle ABC, we use alternate interior angles and found we used alternate interior angles. So we took the bearing of 210 degrees, turned 10 degrees, and subtracted 180 degrees, since this would leave the interior angle measure, which was 30 degrees. Then by the angle addition postulate, we had 90 degrees plus 30 degrees for a total of 120 degree measure for angle ABC. So that was how we found our angle. And then step 2, we first decided between the law of sines and law of cosines. The reason we could not use the law of sines was because there would be 2 missing variables, the angle A and the side length B. So there would be 2 missing angle variables in the proportion equality. We used the formula for the law of cosines as B, and we're going to type in the caret, N2, which is B squared, is equal to A squared plus C squared minus 2AC cosine of angle B. And I'm going to put it at times in there so that we can differ between the side length C and when cosine of B starts. Then, by substitution, we had B squared is equal to B squared is equal to, it was 500 squared. Wait, was that A? Yep. 500 squared plus 1,000 squared minus 2 times 500 times 1,000 times the cosine of 120 degrees. 120. Then we use Google Calculator and made sure it was in degrees and simplified to B squared equaling 1,750,000. Then we square rooted both sides since square root is the inverse operation of a square, and which resulted in the equality E equals 1,322.875. Yep, 875. Which rounds to the nearest whole number of 1,322.88. So the airplane is 1,322.88 miles from the starting point. All right, so there's your project. We can save and then submit it.